I'm Jake Bruton, and today on What Should I Use, we're going to talk about subfloor, subfloor assembly, and everything that goes under your foot. Let's do it now. What Should I Use? A Build Original series hosted by me, Jake Bruton. This episode is sponsored by Advantech Subfloor. Okay, when it comes to framing and subfloors, concrete's one thing, but floor framing and wood floor framing specifically, like we're going to talk about today, that is a total nother beast. There is things in the code that are allowable that then don't necessarily apply when you start talking about what the industry council talks about. And there's a push-pull that happens there where it's allowed by code but not allowed by council. And then we also have the idea of, well, what happens when the client says it feels funny, it feels spongy, or hey, we had company over and this happened, or this feeling was something that we never noticed before. There's a lot of ins and outs here. There's a lot of you don't know until you've screwed it up once. And I think this format today for code, council, and my experience applies better to this topic than maybe any other topic that we've tried so far. And so I'm really excited about this one. Let's jump right in and let's talk about what should I use subfloors. As with every what should I use, our conversation about subfloor and the floor frame assemblies starts with the conversation about code. When I mean code, or when I say code, I mean IRC 2021. That's not the most recent code potentially in your market, or maybe it's a code you don't go by, but in my market, we just use 2021 because it covers all of the places that I build with Aero Building. And today, that IRC that we're gonna start with is Chapter 5. Chapter 5 starts with floor frame and then progresses into subfloor assemblies and a few other things. So let's talk first about our floor joists. So the joist, the span, the support system, everything that's here. We're starting with the way that I started building when I joined the industry some 25 years ago. And that is a 2x12 joist with a plywood sheathing on it. So let's talk about how that is reflected in the code. The code starts with exactly this: sawn lumber that is graded by an accredited grader. And it talks about that first because it's one of the most common methods, and it probably is the one that's been in the code the longest. Second, the code moves on to I-joists. Instead of just saying it needs a grade mark, it says it needs to meet an ASTM standard. That standard is D5055. Not that I know what that means. I'm just giving you that as an example because we're going to see how it works through the code. And so we start with a grading, we move on to an ASTM standard. Next, we could talk about glue lambs. Glue lambs have another ASTM standard. The code, the IRC, actually says logs are okay. Well, how the heck do I know what log to use? It references the ICC 400. So if you're catching a theme here, we start with it's been graded by someone, and we immediately move to it's been approved or tested to verify that it works for someone. We also talk about engineered rim, which is another ASTM standard. But the thing that you'll notice in that very first section in Chapter 5 is that floor trusses are not mentioned at all. And it seems rough to consider the idea that all these things work, and we generally consider a floor truss to be a superior product. It's engineered, it has better spans most of the time, it offers other benefits, and yet somehow it's not even mentioned in the floor joist category here. Well, why is that? Plain and simple is that there is an engineering standard that all of this needs to meet. And outside of the things that I mentioned, like logs or rough sawn or dimensional lumber or glue lambs or engineered materials or engineered rims, the truss just has to be engineered and stamped with the engineer. So this is something that sometimes we forget about in the code. We forget that there is the ability to simply say, the engineer knows what the standard we have to meet is, and so therefore, as long as we have an engineer design this assembly and put their stamp on it and take the responsibility for it, we can use it. That's very simple to just back into. We can kind of do whatever we want as long as the engineer thinks that it meets the code. The next section, 502.3.1, is allowable spans, and I'll give you a cheat code here. We have actually scanned the page in the code book and laminated it, and we keep it in all of our trucks for easy reference. But the allowable span in this section is the distance from framing member to framing member that are the supports for your floor joists. So one of the things that I actually had a hard time with for longer than I would like to admit when I first joined the industry is that I thought span was the length of the lumber, and it's not the length of the lumber, it's the length of the unsupported area that is part of the floor joist. So if we're talking about wall plate to wall plate, we're talking about inside of wall plate to inside of wall plate. So you might order an 18-foot long board and you might have a 17-foot long span by the time you cut it down and you actually have from plate to plate. It's very clear in the code, if you're used to reading span tables, what you're allowed to have there. It's not clear if you haven't been through one of these before. So we get a list of species, we get a list of spacing, and then we get a distance that they will actually carry a live or dead load, and we will come back to that in a minute. That span table will dictate what this assembly looks like. You might actually have an assembly that is too big for a 2x12, or you might actually have an assembly that is too long for a 2x12. In the span charts, we have living area and sleeping area. Why does the code reference living or sleeping different? The reason is you're more likely to have more people in your kitchen, dining, or living room than your bedroom, according to the code at least. And so therefore, there might be a greater load that is happening on that assembly. Meaning, the second floor of your house, where you have 2 bathrooms and 3 bedrooms, probably doesn't have the same torture that the downstairs does, and therefore it doesn't need to be built as strongly. That's one of the things that you have to consider when you're considering your floor choice. We might do something different on the first floor than that we would do on the second floor, or we might do something different in the first floor where the kitchen island is versus where the dining room table is or where the couch sits. Believe it or not, that cabinet assembly that is your kitchen island with that very heavy countertop on it with 9 people crowded around it for Thanksgiving is probably going to weigh more than a few people watching a football game while you're doing all the Thanksgiving cooking. So we have to consider the location within the house, whether or not we need that 30-pound live load for a bedroom or that 40-pound live load for a living area. And all of these things are adding in the code here to kind of narrow our focus for where we're headed with our floor joist choice. Next, in section 502.6, we get to hear a little bit about bearing. And while that section is small, there are a couple things that always come up when we actually have this conversation with my company. I've had a couple people challenge me on the idea that if we're bearing on top of wood, as we are in our mock-up, we only have to rest by 1.5 inches on our support. But if we're on concrete or masonry of some sort, we have to have 3 inches of bearing. Well, why wouldn't we have to just have the same amount of bearing if the thing that we're sitting on top of can't support it? Well, number one, it's about connection. It's that connection between the masonry and your floor joist. It's about the connection between your floor joist and the wood or the beam or the plate or whatever it's resting on. And 1.5 inches is enough because the connection is a more positive connection. And the way that I always explain it is also noted in this section of the code. We get to hear about joist hangers. And if you think about a joist hanger, that bucket that the floor joist sits down in is generally about 1.5 inches. Well, if we have a very positive connection between our floor joist and our joist hanger, then that only requires 1.5 inches. And the same thing happens with a wall plate or a wood beam. After bearing in chapter 5, we roll right into cutting and notching. Cutting and notching is kind of best described by the diagram. The big things to know are not in the middle third, and you really can't do a whole heck of a lot. You can't be heavy-handed with a saw or a drill. There's not a lot of allowable notching that you can do. And this cutting and notching section only refers to sawn lumber. So think of it as the code is making the determination that they know wood species and that these are predictable things, and there aren't different manufacturers involved here. It's all Mother Nature and then just somebody cutting and drawing. And so therefore they use this as kind of the standard. This is the thing that they know, and this is the thing that they can comment on, and therefore they don't make any comments about I-joists or glue lambs or trusses again. So it's just sawn lumber in this section. After the 502.8, we roll straight into subfloor and those choices. And the big thing to understand here is, unless we're talking about dimensional lumber that is going on top of our floor joists, say a 1x8 or whatever, it really defaults to what APA or the Wood Flooring Association or somebody else says. It goes back to an engineering standard, just like the truss conversation does. And now we have to look to what our trade manufacturers associations say, and we have to pay attention to what our product manufacturer says. So we have to look to them to go, does your product meet this standard or that standard? So before we get into what the manufacturer says, let's talk about what the industry associations say. So when we're looking at subfloor, or even floor joists for that matter, what are we concerned with? Well, the code has already made it safe because the code addresses health and safety first. So we're not going to have anything that falls down. So then what would our concern be? Well, our concern would be finishes. Carpet doesn't really play into anything here because carpet is a very flexible material. It moves with whatever the floor is moving or however the floor is moving. But then we got hardwood and we have tile. Now, we're not going to talk about LVT or laminate flooring or anything. We're going to stick with what the Hardwood Association and the Tile Council says. So TCNA, Tile Council of North America, and NWFA, the National Wood Flooring Association, are kind of the two governing bodies that I look to here. We want to make sure that whatever product we buy from a manufacturer and we place on top of our subfloor, we aren't going to have any sort of built-in warranty issue where, well, we didn't build something that was okay to have tile or stone or wood. So one of the things that comes up the most is, why don't we just build the whole thing so that it would accept tile? I think the idea of long-term remodelability or not knowing what the next guy is going to do is great in this instance, and we can talk about L over 360 all day long for the whole house. So you might not have heard that before. What is L over 360? Basically, every floor has a different allowable deflection. How in the heck do you wrap your mind around that? It's a little silly when you start thinking about it from an engineering perspective. It makes a lot of sense. So L over 360 is the load divided by 360 is the allowable deflection of your floor. So when we look at that allowable span, we can look back to the reference chart. We can go for a load of L over 360, which is generally what the code goes for, and with those live and dead loads that are calculated in the code. So under normal operating conditions, we're not talking about parking an elephant here. We're talking about normal living conditions for single family residential. If we have 2x12s that are 10 foot of span, meaning 10 foot from plate to plate with a quality subfloor, we then only have to, this would be 10 for 10 feet over 360. That would be 5/16 of an inch is what the allowable deflection in that floor is. And that movement is enough to ensure that we're not getting beyond a cracking point for our tile or an adhesion issue for our tile where mortar's being displaced to a point where it has problems or anything like that. So L over 360 is literally the length of the span divided by 360 gives you your allowable deflection, and the engineer can calculate your deflection depending on what your floor joist is at that point. So by building to that, we'll call it a TCNA standard, even though it's adopted into the code. The Tile Council of North America now has given us a metric by which we can go, okay, we can put tile in here at any point and it'll be fine. So if the clients put wood in the downstairs bathroom and a toilet leaks, and they go, okay, well, we don't want that wood anymore because it's falling apart. We don't want to have to refinish the whole house. Let's just cut it at the door and put in tile. Great, we've already designed the building to accommodate that sort of a thing. That doesn't take into account natural stone. When we're talking about natural stone, it's actually L over 720, which means that number has to be even smaller. So in this instance, it would be half of 5/16 that would be that allowable distance. That's not much movement. That means it's very rigid. Rigid can be good for some things in building. rigid can be poor for some things in building. Knowing when and knowing why is kind of half the battle. So I have 3 mock-ups for you today, and I want to kind of point and poke at each one, talk about what we have going on, and talk about why I would pick one over the other, and how I would encourage you to find your own criteria that works for you on your job. Let's go through our mock-ups now. In mock-up number 1, we really are looking at my old school, my version of what I built when I first got into the industry. In mock-up number 1, we really are looking at my original introduction into floor framing. I was not around for the dimensional sawn lumber on the top. We started with plywood when I joined the industry in 1995. And we have 2x10s that are Doug fir, and we have 3/4 T&G plywood. This actually came from a local home center. It doesn't even have a brand on it. I'm sure they know what brand it is, but it does carry an APA stamp that says it's okay. And we have kind of the 2 standards that I built when I was working for the family business when I was young. That's 12 inches on center over here on the left and 16 inches on center here beneath me. That means we have 14.5 in between our framing members, and that's the furthest that this 3/4 ply ever has to actually span. We have a very sturdy, very duplicatable version of a subfloor frame, and let's talk about why this was what it was when I started in the industry. Number 1, the OSB or particle board or wafer board, whatever you want to call it, industry was not as popular, and so therefore the I-joist was not really a thing. Floor trusses certainly existed, but they were not something that was cost effective at the time, especially where I started in Columbia, Missouri. There really wasn't any plant running those that I was aware of at the time, and so everything just kind of defaulted to the Doug fir 2x12. Sometimes a 2x10 depending on framing. And this is a subfloor assembly that served us well, that actually still comes into place from time to time, especially when we're talking about 2x12s or 2x10s, dimensional sawn lumber. That is something that remodel situation where we're matching heights, a small addition maybe, where we have a crawl space or a basement and we have a relatively small addition. This is something that I can drive to the lumberyard down the street and pick up darn near any day of the week. I don't have to special order a few I-joists. I don't have to worry about wasting a bunch of cutoff on I-joists. But as we talked about in the code section, when we start talking about cutting and notching, there is not a whole heck of a lot that we can do in the cutting and notching realm. When you put this over a basement that you might want to finish at some point, now all of a sudden we have tons of soffits built down below because we have plumbing lines or ductwork that can't transfer through these, that have to navigate their way through this. So we are limited, both span, load, and everything that's happening around it or below it. It's served its purpose and it's still seen from time to time, but I think if we move to model number 2 or mock-up number 2, you'll see something that is just like an ever so slight upgrade that gives you a little bit more versatility. But I think that will be clear if we go ahead and swap to mock-up number 2. Let's do it now. Okay, we're back with mock-up number 2, and what we kind of have here is something very similar to the first one, but slightly different, and it carries with it different connotations. The why and the how, and the how we get to this. Let's start with, what do we have? Well, we have I-joists. We talked about I-joists earlier. They're covered under ASTM standard, and the code approves it, but you gotta look at what the manufacturer says. You need to be understanding that manufacturer's span charts. You need to understand what they say and how to treat rims and things like that, and the nailing pattern. But for the most part, we're looking at an engineered version of the 2x12 that I was sitting on a couple minutes ago. The only difference is this engineered version in some world is actually closer to a floor truss than it is dimensional lumber, because this system comes with pre-drilled knockouts, and you would go, oh, well, if I take it out, I actually weaken the assembly. Well, not actually. They already drilled it out. They just didn't bother knocking it out of the factory because it's not worth their time. Those holes are pre-drilled. We can do whatever we want to run wires through those holes, but generally speaking, you're not allowed to cut or notch this in another way unless the manufacturer says you can. Some manufacturers publish so that you can actually just find what size hole you could drill or cut, because you might see ductwork running through these from time to time. Other manufacturers give you a pictorial version of what you can drill or cut, but we're still pretty limited. We're not quite where the 2x12s are, and we're not anywhere close to what we'll see in the floor truss mock-up in a minute. We have kind of the same spacing and layout that we show in the other one. We have some 12-inch on center. This is Black Diamond 19.2 inches, so instead of the 16 from center to center or 12 from center to center, it's closer to 19.25 inches for argument's sake. We have a little wider span. We spend a little less money on floor joists. We're able to utilize a 3/4 subfloor still. This subfloor we're showing in two different methods here. We have Advantech. Advantech is a premium subfloor product that we at Aero Building have been using for nearly 20 years. The difference between it and some of the competitors when it comes to an OSB or oriented strand board is kind of just what kind of glue they use and how much of it they use. We find that it weathers really nicely, but they've also introduced X Factor, the yellow coating, and we've used that a few times now. I like it for markability standpoint. However, when we go back to that conversation about TCNA, the Tile Council of North America, or the Hardwood Flooring Association, this facer that they put on their regular Advantech, basically just a facer, if you tape the seams and detail the seams, I now carry a vapor retarder that is approved by the National Hardwood Flooring Association. That's key if we're talking about a crawl space market where we may have an unconditioned space below, or maybe even a tuck-under garage. And so now we've utilized the ability to bring one more added product to the market, or one more added product to the job site without one more step. So now I don't have to lay down or roll on any sort of vapor retarder, and we've just kind of tweaked what we're doing a little bit. In this instance, the important thing to know is that, once again, we're referencing what the manufacturer says for allowable span, and for allowable span both for the floor joist and the subfloor. And it's important to note that this is pretty much the furthest that I'm willing to go, and that the manufacturer says you should be going with the 22/32 on subfloor for Advantech, because now we're getting very close to that L/360 number, and we go to any further than the 19.2, or as we call it, Black Diamond, and we can't put tile on this assembly. So we have our limitations both in this instance from our floor framing member and our subfloor, just like in any other assembly, but it's the knowing what the manufacturer says and not what the code says, and what the manufacturer says and what the code says. I like this assembly. In my market, I would say my criteria is it, until very recently, has been difficult to come by I-joists in multiple different lengths. There was kind of just some stock stuff kept on hand from a few different manufacturers. So if we have an engineer that likes a certain I-joist, or if we have an architect that has their preferences, we run into, well, how long is it going to take to get that? On the flip side, we've been able to get Advantech any day of the week for quite some time, so it's very easy to adhere to something like that as being our standard. From here, we go from our old standard to a not as old standard to our new standard when we bring up mockup 3. And so I want to take a break, roll that in, and talk about why we are now using those choices. Let's do it now. Okay, so mockup number 3, very different look, different things happening. What do we have here? Well, we have, they're not real trusses, because we didn't want to have to try to describe to our truss guy that we wanted 4-foot wide trusses that were 16 inches tall. So we built our own. We have 2x4 assembly with some mending plates. We could have top hung. We could be supporting off of a wall. We have varying spacing here. What we're showing is 24 inches on center. So center to center is 24 inches. And we have 1.125" subfloor. I would describe everything that you have here as considered and very high quality and very well planned for, and also substantially less cost effective than the two other versions that we looked at. That doesn't mean it's right or it's wrong. That's part of the decision-making criteria in any project, right? We're talking about availability. Well, these guys are special order. The I-joists may be special order. The 2x12s probably aren't special order. We're talking about the ability to put things together. Floor trusses that are 16 inches tall may carry a different weight factor than a 12-inch tall I-joist, and therefore we may end up having to have a crane on site to set things. Or we may end up having to special order and plan really far ahead, and then we get a building material that can't be cut or altered on site that now is too long for the building that we've built. So there certainly are challenges that were actually a big barrier of entry for me when we decided to make a switch to floor trusses, everything I just talked about. However, when we start talking about the benefit of floor trusses, the 24 inches on center from framing member to framing member here is substantially less. So we could actually be a 7/8 subfloor if we were looking in the Advantech family. Check your manufacturer's ratings for that. Or we could be an 1.125" and still be 24 inch on center, because the 24 to 24 point is from edge to edge or center to center. Well, this is a wider framing member when we're looking at a 2x4, and so therefore this space is a little less. That span that we're asking our subfloor to bridge is a little less. This is something that could be 12 inches on center, 16 inches on center, 19.2. I think the benefit of going to a floor truss that we're having engineered, we probably wouldn't run into a situation where in single family residential we need 12 inches on center. The loads that we create in our buildings are not something that floor trusses have a difficult time with. The other big benefit of a truss assembly is, like I said, when I stuck my arms through there, or you can see underneath, we have a 10-inch round insulated duct running through the assembly, and that could continue all the way across because we have a box out built in the end of the trusses in which we have the ability to run plenty of building materials. So if you take, for example, our Spring Valley Aero project, which was my personal house, we have plumbing at one end of the building, we have floor trusses, and we have a 3-inch drain line that transverses the living room ceiling, the kitchen ceiling, and all the way to the other end of the house, some 45 feet away before it turns vertical to do away with that waste. That gave us the ability to run that line and not take up exterior wall insulation space and compromise part of our wall assembly. Somehow, floor trusses end up being a building science benefit in that situation. The other thing that happens is we don't have to drill any holes. We don't have to use a hammer to deal with any knockouts in our I-joists. We just simply run things through here, staple wires down, add pipe hangers, whatever it may be. And now we have a much more versatile joist assembly. It's also likely that now we have added costs when it comes to things like our stairs or our siding or our exterior sheathing, because we are actually increasing the depth in most cases. I'm not sure if I've seen a floor joist and a floor truss under 14 inches in height. I think that we're talking generally 16 and up, depending on your needs. It also, like I said, you could top hang. So if you were looking at a basement wall, you could hang from a foundation wall. You could pour the foundation just a little bit taller, but yet keep your entry level of your house a little bit lower, because we could drop the majority of this, if not darn near all of it, below that foundation line and push that a little further into the ground potentially. So let's talk subfloor. If we're talking 22.5, we're still 7/8 or 1.125". If you've worked with 1.125" subfloor, you know that it is not an enjoyable thing to pack around the job. So while we have what seems like it might be a lightweight building material in the trusses, we have a substantially heavier product on the 1.125". I've used 7/8 multiple times when we're talking about 24 inches on center. For my money, it is not worth it for me to order 1.125" or 7/8 simply because they're special order. I don't want to have 6 pieces of subfloor floating around at the end of the project if I can avoid it. I would much rather see a 3/4 material if possible. Also, there is a cost savings associated with using something that, even if we're not talking about quality of product or anything other than availability, if the yard stocks it, chances are they're buying larger bulk and it's a little more cost effective. However, this is an absolute bomb-proof floor assembly. When we go back and we look at TCNA, the Tile Council of North America, the challenge here is, even though we go to 1.125" and we might meet that L/720 that they require for natural stone. I think most of the natural stone requirements still request a double layer of floor sheathing so that you can offset seams and reduce the potential of cracking. So therefore, now we're putting a hefty layer or a hefty second layer on top of this, and we're doubling down even more. At that point, I would rather see 2 layers of 3/4. So while we looked at these assemblies and we said kind of a good, better, best, I actually think for my money, it's a hybrid of what we have going here. We have a floor truss would be our go-to product because of the versatility that it offers. And when we talk about spacing, generally we're framing our walls with my company Aero Building 24 inches on center to optimize insulation, but we're back to framing our floors 16 inches on center whenever we can, or a 19.2, which is slightly uncommon even in our market, so that we can use a 3/4 subfloor assembly and kind of have the best of both worlds. Like, I'm literally saying we special order trusses, but we don't want to special order special thicknesses or larger thicknesses of our subfloor material. So in reality, we kind of have a conundrum here. We get to the end of our episode and we're talking about subfloor and subfloor assemblies, and I don't have a recommendation. What I have is a suggestion about the criteria that you should use to make your own recommendation. We start by talking about what the code says and the why behind the code, and then my criteria always goes to what does the industry association or council have as a recommendation, how does that affect my building or my clients, and then I look at what's right for my budget, my area of building as in my location, our carpentry team, what's going to be best for them, what's available in our market, and all of those add up to a rather large equation that then leads us to, well, this should be an apparent decision by the time we get to that. And if it's not, then it's probably not that important. So using that method, you should be able to develop the criteria for yourself as to what's right for you, your team, your budget, whether or not the code allows it. And now you have the decision-making ability to decide what you should use. Stay tuned for the next episode. Thanks for watching.